morning, everyone. Welcome to this webinar that will take us for a discussion and conversation for 1 hour. So I will quickly do the role of moderator. So I will try not to take too much time and give the room to my colleagues, which are here with me. Some are with me here in Luxembourg, and we have Dave, which is based in the UK. During this webinar, you will be allowed to ask questions by written. So you should see somewhere on your screen a Q&A button. So you can click on this button and type your question, and we will receive it, and we will do the question and answer at the end of the session. So let me okay, so first of all, I will give the floor to Marion. So Marion is a civil engineer with a PhD in structural fire engineering. She provides technical assistance to engineers and architects, mainly related to structural fire engineering and sustainability. Marion is involved in the decarbonization initiatives of the steel construction products and regularly teach training for practitioners, and is an active member of several technical committees for the revision of Eurocode. Marion is part of our team here at Stelligence, and she's in charge of the market for Benelux, UK, and Nordic area. So let me give the floor back to Marion. And
thanks, Pascal.
Okay. Yeah, and one last thing, I will present each of the speaker as they will come during this presentation. So the floor is to Marion.
Hello, everyone, and thanks for joining our webinar. I will make a quick introduction about the current context that we're facing and main initiatives that we're launching here at ArcelorMittal, or X-Carb initiatives. And I would like first to start with this slide, which was prepared by I/E in the UK, and which clearly highlights the role that we have as structural engineers to face climate change, in a sense that we may have a much bigger impact than any other people. In a sense that you see here a couple of numbers, you see the gains that anybody can achieve in terms of CO2 equivalent by personal initiatives such as stopping and cutting one flight, stopping eating meat, dairies, and alcohol, stopping driving your car. All of these are, of course, very relevant initiatives, and they can help you to save some carbon impacts. But if, as a structural engineer, you manage to achieve a 20% reduction of the embodied carbon in your buildings, you can see that the order of magnitude in reduction that you reach is completely different. And so this is just to stress the fact that we really have an important role to play here. Next slide, please. And indeed, another important number here, we can see that construction consumes approximately 50% of the total steel production worldwide. So once more, this just to underline the fact that we are, as construction stakeholders, should really go on board of decarb initiatives as material manufacturers, but also as designers, architects, and so on. We really have a key role to play here. Next slide, please. This, once more, is something which has been prepared by I/E, and it provides a hierarchy for a net zero design. And it shows which priority we should give to different strategies when we want to design and drastically reduce our embodied carbon footprint. First of all, I mean, it seems pretty logical. It's better to build nothing. Is it really needed to build something? Then we can also work on building less, meaning working on refurbishment, reuse, which is something that can be leveraged thanks to steel products, because we know that structural steel has many advantages for structural use. We can also build clever in a sense that we should use appropriate grids, use appropriate structural systems. When we talk about steel, we should rely on high-strength steel when relevant. We should really put in place clever structural systems, build efficiently. And here comes the low carbon materials. So this is something we will highlight today. What do we have? What do we do? Which products do we provide on the market to meet this low carbon material demand? It is really important, but it is part of a bigger picture. And finally, we have the minimization of the waste while improving the construction practices. Right? So now we focus on X-Carb initiatives. X-Carb is the name of the label of everything which is taking place within ArcelorMittal to decarbonize steel production. Here on this slide, we can see, I think it's important, first of all, to get a rough idea of the global distribution of the steel manufacturing worldwide. So these numbers are coming from World Steel Association, but within ArcelorMittal, we somehow follow the same trend, in a sense that we have a big majority of the steel which is produced from the blast furnace, basic oxygen furnace routes. A very small percentage at the moment through DRI, direct reduction iron. And these two production routes are labeled as primary steelmaking routes because we're using iron ore. And then we have roughly 1/4 which comes from EAF, electric arc furnace routes, which is using scrap, and so which is based on recycling, and which is usually labeled as secondary steelmaking. So when we see these different production routes, we understand that we need to work with these three, and we need to come up with strategies to decarbonize the different routes. We cannot only focus on one, we need to work with the three of them. Next slide, please. And here once more, we have a little table that shows us which are the different production routes. And here we have an example for section and merchant bars products. So we can see, for example, if we start from the left, the blast furnace route, which uses coal and iron ore as main inputs. We have the coal, which plays the role of the reductant. And as order of magnitude in terms of carbon emissions, we can have as an order of magnitude, it's a worldwide average, we can have in mind 2.5 tons of CO2 equivalents per ton of steel. Then we switch to DRI. DRI plus EAF, where we're still using iron ore, so still primary steel making, but instead of using coal, we're using natural gas as reductant. And here, in terms of order of magnitude, we roughly divide the number by 2, so we are roughly at 1.25 ton of CO2 equivalent per ton of steel. Then if we go to EAF, using 100% scrap, which is what we do here in Luxembourg to produce our sections, we once more divide the order of magnitude by 2, roughly 700 kilos of CO2 equivalent per ton of steel. And then if on top of that, we are still using EAF, but with renewable electricity, we can once more divide roughly by 2 the impact. So this is to show you, to give you some order of magnitude, to understand that if we are working with one production route or the other, of course, first of all, we are talking about different carbon impacts, but also we will be talking about different decarb strategies and different timelines. Because depending on the production routes, some low carb solutions already exist or are ongoing, and it's important to have a good understanding of all of that. Next slide, please. Here on this slide, you can see ArcelorMittal decarbonization plan towards net zero situation. This is our roadmap for the whole group, so worldwide. And you can see that this roadmap is based on 5 main pillars. The first one is based on steelmaking transformation. So what is behind this word steelmaking transformation? We will slowly transition from our blast furnace, basic oxygen furnace sites towards DRI plus EAF. So we will really make significant changes, industrial changes on our production sites. Then the second pillar, energy transformation, we will be leveraging on cleaner energy. There is one example, which is the Steel initiative in our site in Ghent, where we are using the blast furnace gases that are transformed into bioethanol, which are used, for example, in the transport industry. These kind of initiatives are gathered under this pillar, energy transformation. Then under the third pillar, C, increase use of scrap. Of course, if you remember the orders of magnitude from the previous slide, you remember that the EAF route provides really low embodied carbon. And I mean, it seems quite logical. We need to recycle as much as we can. We need to leverage on the scrap which is available to recycle the steel. Then the pillar D is sourcing clean electricity, and pillar E, offsetting. And as you can see on the slide, the offsetting comes at the very last. It is the lowest priority because we fully realize that it is the first pillars which are the most important and which practically will decarbonize our industry. Next slide, please. Here, steelmaking transformation. So the first pillar, as I told you, we will transition from blast furnace to DRI. So today, DRI is working with a natural gas. And first step, it seems simple said like this, but it's actually quite complex. We need to switch from natural gas to hydrogen. It means that we need to make our installations to be technically operational, working, sorry, I'm losing my words, with hydrogen instead of natural gas. At the moment, most of the hydrogen comes from petrochemistry, and we usually label this hydrogen as gray hydrogen, which makes it a not really sustainable alternative. But there are many developments ongoing to source green hydrogen. What is green hydrogen? It is hydrogen which is obtained through water electrolysis. And using this, we can strongly, significantly decrease the embodied carbon through the DRI process. So this is what we're currently working on. And if you go on the next slide, you will see all of our sites which are already announced the fact that they will switch to DRI plus EAF. Sestao in Spain will be the first world full site which will reach the net zero thanks to this switch. It will be working starting from 2025, and it will be able to produce around 1.5 million tons of steel per year. So it is a significant step towards our decarb objectives. If you go to the next slide. I think it is also important to tell you that, okay, now we're making a rough summary of what's happening, but if you go on our corporate website, you will be able to see all the updates towards our targets, in a sense that it's, of course, very important to have a solid and robust roadmap, but it's equally important to communicate on our progress, where we are, what has been achieved so far. And so here you can see some headlines, but of course you'll get the details, all the details on our website. But you can see that we have strong deals in Spain, in Germany, to secure the sourcing of renewable electricity. We have first DRI EAF site in Canada, which has been launched very recently. Everything is transparent, and it shows that we are indeed making progress, and it's important to show that we are moving forward. Next, please. In terms of scrap, we are currently buying scrap from open markets, but recently ArcelorMittal has acquired scrap businesses because we really want to make sure that we will source the right sort of scrap. So this is also something really important to know. Next, please. And finally, here. Before leaving the words to my colleagues, I will just very quickly tell you that within the XCarb umbrella, we have mainly three families. The first one is the Innovation Fund. The company is investing $100 million per year to this fund, and this money is actually not going to ArcelorMittal itself, but to fund other companies which we believe are necessary to achieve our targets. So we're collaborating with other companies to make sure that we're making synergies to reach our targets. Then we have the Green Seal certificates. Through these certificates, we are quantifying and putting, let's say, quantifying all the savings that we do in terms of CO2 emissions, and these savings are externally certified, externally validated with DNV, and we can provide these certificates to our customers so they can actively reduce their Scope 3 emissions. And then the final and last family is the recycle and renewably produced family, which covers the products made through the recycling route, EAF, with scrap and renewable electricity. And I think I have taken too much time. I'm leaving the word to my colleagues and starting with Dave for the sections.
Thank you, Marion. So I will, before giving the floor to Dave, so let me switch screen on my side. So Dave is a chartered structural engineer and has worked, in the steel industry since 1986. Firstly, with the fabricator Westcall, Blossford and Dyer, involved in Stadia warehouse office projects, where he became technical director. Subsequently, 20 years at Corus, Tata Steel, BCSA as technical manager. Dave is one of our last newcomer in the Stelligence team, as he joined in 2023 with a similar role as responsible for specification of the company's various products within the UK market. So, Dave, the floor is yours.
Thank you, Pascal. Next slide, please. And of course, thank you everyone for joining. This is a busy slide. I'll start on the right, just to say that ArcelorMittal is able to produce many grades, you can see there, including weathering steel grades or branded as Arca rocks. In the middle, various shapes and sizes of steel can be rolled for various countries and various country codes as well, not just 10365. Of course, cellular beams on the bottom. There's three options there. I'll talk about sections though, and the various sections that we can produce in our Luxembourg mills are very impressive. For example, the beam on the left there, we can produce them up to 1377, 1/3 tons, much heavier than other manufacturers can make, shown orange there. Typically, these would be used for big spans, but also commonly for bridges. That's very popular now. And the column sections to the right are going very, very heavy sections. Again, 1/3 tons per meter run, twice as heavy as what is commonly available. And these have been very well utilized within high-rise buildings and also parts of transfer structures as booms in some heavy trusses. Next slide, please. The UK has a demand of about 12 million tons of steel per year. That's everything. And has an internal capacity of about 6 million tons plus, something like that. So 50% of our steel in this country probably needs to be, or it does need to be, imported. And part of that is our structural sections from the mills in Luxembourg and in Spain. So Differdange and Belle Valley in Luxembourg, and Bergera and Oliveira in Spain. And these are all electric arc furnace mills that are being used here to supply the UK. It's not a new thing. ArcelorMittal has been importing EAF steel to the UK for 25 years now. So it is just there at stockists. So probably in terms of structures, supplying along with other manufacturers, about 40% of the structural market. And that's being stocked in various places alongside blast furnace material. Typically there'll be 2 or 3 boats per week, up to 5,000 tons coming in. So there's regular supplies, and these are being stocked. The larger sections we spoke about earlier, they're rolled per project. They're not stocked readily, but as long as we know that they're coming, we can ensure that they are rolled for that particular need. Next slide, please. Many of you, of course, have seen this. This is an EPD, or an Environmental Product Declaration, a method of measuring the energy used to make a particular product and lots of other things. There's 20 other lines of information on this certificate, some of which I'm not sure what they are, but certainly one I can read is GWP, Global Warming Potential. And this shows that the sections we're producing are at 333 kilograms of carbon equivalent per tonne, modules A1 to 3. And it's not just construction industry now that's using EPDs, it is other industries that have taken on this format. These certificates are renewed every 5 years, or indeed when the manufacturer wants to. There are calls for site-specific and product-specific EPDs. Some can be done, some can't. Next slide, please. An example of where our X-carb sections sit in the world compared to all steel is the largest red column, and then the average for sections is significantly lower, and there's great carbon savings to be made by selecting the right material. Next slide, please, Pascal. So far we've been talking about carbon in terms of carbon per tonne for our particular product. But to be useful and applicable for other people, the metric of per metre squared for a building is helpful. Now keep clicking, please, Pascal. We're going to look at a portal frame here. That's what that'll do. And know a lot about sheds and portal frames. So we're going to look at the elements cladding, purlins, frame and slab. And was about 13 kilograms a metre squared for the cladding, just considering the steel. I looked at the foam and it was getting too complicated, just considering the steel element of it. That multiplies through 13 kilograms metre squared at 2.72 tonnes per tonne. It's equivalent to 35.4 kilograms of carbon per metre squared. So there's a good metric we can use there. And looking at the purlins, something similar. And of course, the frame is a big element, 45 kilograms metre squared, reasonable. And that gives us 110 kilograms of carbon per metre squared. Totaling all those things, including the concrete slab, regular concrete, there's no GGBS in that, gives us a total for a building of 230 kilograms per metre squared. Now that's regular. If we consider our X-carb offering, slightly lower for the cladding, again achieving 13 kilograms. Purlin is a bit lighter as well, at 5 kilograms, being 1,000 kilograms per tonne. The X-carb, significant savings there of about 95 kilograms of carbon per metre squared. And again, the slab, I haven't put any GGBS in that to reduce it, but of course that can be done. Next click, please, just one. So we've got we have a reduction there of over half just by selecting certain materials. And that's pretty significant. And next slide, please. Oh. And again, considering the metric of kilograms of carbon per meter squared, along the bottom we have different kilograms a meter squared for buildings, i.e. light buildings going along the horizontal axis to very heavy buildings, and up the vertical axis is our kilograms of carbon per meter squared. So these lines have been plotted, showing, of course, that the more material we use that is low carbon, the greater the savings will be as we choose, as we go along. Again, still sticking with kilograms of carbon per meter squared for a particular building. You may have come across LETI, originally the London Energy Transformation Initiative, now changed to the Low Energy Transformation Initiative, which is fine. Currently, it says best practice there. If we look at that lower pink circle, 600 kilograms carbon per meter squared as a target. We have people coming back to us now, checking this in arrears. Speaking to one engineer recently who said that there's someone on site checking it wagon by wagon so it can go along. And I think this is the way things are going now, so we can check our carbon input as it's happening on site, or at least plan to do that rather than in arrears. I want to draw your attention to 2030, which is the boxed pink number of less than 350. Now, that's coming quickly now, 2030. And if we consider the proportion of superstructure by the box on the bottom, that's saying 48% of a typical office block could be superstructure, being frame and flooring. So we take 48% of 350, gives us a superstructure target of 168. Next slide, please. Click, please. And you'd have to believe me, similar sort of slab density for carbon of 68 leaves us with a frame allowance, whatever it is, of 100 kilograms. So considering our regular UK mills at 2.5 tons per ton of carbon, that amounts to 221 kilograms. So that isn't close enough. Whereas an X-carb alternative, as shown here, can amount to 30 kilograms carbon per meter squared. So it could still work. 2030 is coming. Next slide, please. Although we're talking about X-carb as a product, and it goes hand in hand with sharp design, and by having a sharp pencil and considering high strength grades, we can get some other benefits. I'm combining the two here by introducing High Star. High Star is a material that starts at 460, the red line in the middle, and doesn't decrease at all until it gets to 100 millimeters thickness, and then it only decreases by 10 units per millimeter squared. Whereas a standard 460, that blue line going down, of course, decreases as normal in the code, 16 and 40 and 65, etc. There's a big benefit there to using high strength material over normal 460, but even more so, 34% over S355 when it comes to the very big sections. Next slide, please. Just consider a simple example. A regular column, heavily loaded, 12,500 kilonewtons there. Another metric we're introducing now, which I'm sure we're going to see more in the future, carbon per meter of element. And in this instance, it's 833. If we look at a higher strength material in the middle, 460, goes down a bit, 576, but introducing X-carb on top of that material saving down to goes down to 78. So in this instance, not only is there a mass reduction, 30%, and a clear CO2 reduction, but the overall cost goes down. There is a cost for S4 high star 460, and there is a small cost for X-carb, but it's still overall more economical. Next slide, please. I'll finish here. Some examples where high star and X-carb have been used. Worship Square recently topped out, and there are many high-rise buildings in the pipeline that have got these sections specified and designed in already. There's a stockist on the right-hand side. Stockist on the right-hand side, putting the money where the mouth is. 650 tons of X-carb used to build that structure. And finally, a super transfer structure, nice communal area at the bottom there. Thank you for listening.
Thank you, Dave. So I will now give the floor to Frédéric. Frédéric has been working for ArcelorMittal Group since 2000, mainly in commercial functions, attached to our group's heavy plate mills based in Belgium, France, and Spain. Today, he is professionally located in Luxembourg and works as technical support and sales manager for a Spanish heavy plate mill. The floor is yours, Frédéric.
Yes, good morning. So let's talk a bit about heavy plates made of steel. In short, what are we talking about? Heavy plates are used for the construction of private and public buildings and also infrastructures. Also there are applications linked to the construction of bridges, of offshore or onshore wind towers. Also, you can change the slide, please, with the different applications. Okay, so also in shipbuildings, yellow and green goods, etc. So the ArcelorMittal production mill for heavy steel plates is actually located in Spain, in Gijón. This is in northwest of Spain. The plates feasibility range of this mill in Gijón goes from thicknesses starting at 6 millimeter up to 150 millimeter thick. The width go up to 3.3 meters width. Length up to 25 meters, and the plate weights can be produced up to 19 tons, more or less. So this is a real competitive advantage since the markets, or since specific markets, for instance, windmill towers require heavy plates with increased weight. So at ArcelorMittal, we are currently excited and proud to present a new offer for heavy plates green steel. It is under our X-carb green steel umbrella, which already was introduced by Marion before and also Dave. And here we are talking about recycled and renewably produced, so the so-called RRP, X-carb RRP heavy plates. So these heavy plates use slabs. So slabs is, to make it short, it's the raw material or the primary product to produce the steel plates. And these slabs are produced in an electrical arc furnace, the EAF that we already also explained. And this EAF is working with almost 100% of very high quality scrap, and uses 100% of renewable electricity, which comes from wind energy, instead of the classical routes using blast furnaces with coal and iron ore. So here we are really talking about green energy, so green electricity, and scrap. So scrap, as you know, is recycled steel coming from various industrial, construction, or automotive, or even household origin. So this XCARB RRP allowing us now to certify CO2 footprint for our plates of 0.9 tons of CO2 per ton of steel. And this is on a life cycle basis, so the cradle to gate approach. And this is documented by an environmental production declaration, so this EPD, also explained by Dave before. And it is brand new, it is available since October. And this is also a real competitive advantage on the market. So the scheme below, I don't think we have to explain. This is just a very short information on the steel making process using an electrical arc furnace. So in short, the steel is obtained by melting scrap and in a furnace, and the liquid steel afterwards is then transformed to slabs and then rolled to the finished plates. To resume, and thanks to the XCARB RRP plates, we can today offer a real physical steel plate with a reduced CO2 footprint by more or less 65%. So you see the industrial process chain, it looks like this. So the slabs are produced in another ArcelorMittal mill and then transferred to Spain, to Gijón. And the plates are then rolled and processed in our mill, in our heavy plate mill in Gijón. And it's all this together, if we count all the CO2 accounted on each step, on each process, we achieve it's a best in class for this kind of product, actually a value of 0.914 tons of CO2 produced by tons of steel. So this environment preserving performance benefits also to other steel elements, you know, in the construction, like welded sections, which is a key component in building and the bridge construction. Welded sections that are based on XCARB RRP heavy plates have a CO2 equivalent footprint reduced by approximately 60% compared if they would have been produced with conventional heavy plates. So this is really a huge improvement. So typically 18 tons heavy plates used in major infrastructure projects, for example, in welded section, or even box girders for roads and rail bridges. So using these RRP steel plates in civil engineering projects, allowing to reduce the Scope 3 emissions and contribute to a much lower carbon footprint for infrastructure projects. Actually, the Scope 3 applies to the emissions coming from the supply chain. So maybe I can explain this a little bit later if we have some time left. And so it's also important to know that this significantly lower footprint is documented officially. And that's why we have this EPD, this Environmental Production Declaration, which is available. So this is this document that can be downloaded and goes together with the RRP plate, heavy plates. Alternatively, also interesting, I think, to mention, it has also been mentioned shortly by Marion before. So we can also offer XCARB with green steel certificates. So these green steel certificates are designed for the conventional steels, so the ones made by blast furnace route, that uses coal and iron ore. So in this case, we are not speaking about the real green steel. It is a classical conventional steel heavy plates, but together with the certificate. And just to explain shortly, so the approach of the Green Steel Certificate, or JSC. So the CO2 savings are achieved in our different industrial facilities throughout Europe. And so not especially in the Spanish mill, but in other industrial sites. And so for instance, thanks to the investments we are doing in this, or process improvements leading to lower the fossil coal consumption, to keep it short. And all these savings are then transferred to the users, to the customers, by purchasing these certificates and via a dedicated registry. And all these savings are verified officially by a third party, an independent third party. In this case, it is DNV. So it is something which is recognized, which is official, and it's again certified by the DNV. So, and to finish the information on heavy plates, and the last slide, I think it's yes. Here, yes, it seems a bit complex, but to conclude this, thanks to this certificate, it contributes to reduce the CO2 emissions from the scope 3 as per the Greenhouse Gas Protocol Corporate. So the EPD we give for the conventional steel produced in Gijón has a global warming power of 2.6 tons of CO2 per ton of steel. And by purchasing this certificate, this value of 2.6 drops to less than to 0.488 tons of CO2. So this is significantly lower. And again, so this can be deducted from the scope 3 emissions. Thank you.
Thank you, Frédéric. So I will give the floor to our last colleague before Marion, who will do some final words at the end of the presentation. So Jordan has an academic background in international economics and has been working for ArcelorMittal Tubular Products since 2017, starting with transversal functions such as marketing and transformation. Nowadays, he's also located in Luxembourg and is actively and mainly involved in sustainability. The floor is yours, Jordan.
Thank you, Pascal. Thank you, anyone, for joining us today. On next slide. Before diving actually into the details of our supply chain, a few words of introduction concerning the steel tubes. This is downstream product which contains a lot of carbon emissions. But because carbon is an invisible gas, it can be quite hard to assess its impact. So here, I've listed a few examples. If we take one single tube with standard dimensions for construction, it could be the same carbon emission as flight from Paris to Bucharest, or a journey driving with a car of 1,100 kilometers. That would be roughly Milan to Amsterdam. So a lot of emission for one single tube. If we take 1 ton of steel tubes, moving forward, the next step, this would release into the atmosphere 2.3 tons of CO2, roughly the same carbon emissions as more than 1/3 of the total annual emissions of European citizens for a year. To Frankfurt to Sydney flights, or a lot more items, 440 t-shirts, 1,500 meals, a lot of cup of coffees, etc. But luckily, next slide please, even if steel tubes contain a lot of carbon embedded in them, they can also be part of the solution because it's our responsibility as a steel tube producer to decrease the carbon content and to offer alternatives. And steel tubes can also be a solution in this transition towards the build efficiently that Marion mentioned in the introduction, the smart design and the sustainable construction, because it can be used almost anywhere actually, building cranes, in scaffolding, in structures and frames of building, in sprinkler systems, even in renewable electricity generation, such as solar panel structures, the skeleton of windmills, etc., etc. Moving forward on the next slide, a lot of things have been moving recently within our division to realize this vision, especially since last year, actually. And it can be split broadly in three main categories: sourcing, cleaner material, production of low carbon steel tubes, and transport. First, then, the sourcing of low carbon emissions material. Here, we wanted to make the most of the X-Carb initiatives from the group with the X-Carb recycled and renewably produced coils from Sestao. This is the raw material that we use to produce tubes. And as you can see in this graph, this is the bulk of the carbon footprint. 95%, around 95% of the whole carbon footprint of a steel tube is composed of the hot rolled coil. So this is what has the most impact. And taking advantage of this X-Carb coils from Sestao, we could divide by 4 the carbon footprint up to minus 75% CO2. Moving forward to the second component of our supply chain. This was also strategic because our production site, Fabril, in northern Spain as well, is really close to Sestao. So we could also reduce the carbon negative impact of the transport of the raw material to the production site. But we also wanted to go one step further and to use for this production only green or renewable electricity certified by Guarantee of Origin certificates. Thanks to all that, we are able to produce and offer for the first time in Europe low carbon emissions hollow structural section according to the standard EN 10219. More is in development. Stay tuned for the next releases. But it's also available in various coatings such as Sensimir, galvanized, magnelis on. Moving forward to the next slide, the last component of our supply chain, we also wanted again to go one step further, not to be just cradle to gate, but to also propose some alternatives for cleaner transportation. And according to a study made by the European Environment Agency, the little graph that you can see on the slide, the transport modes that have the least impact, negative impact, are ship and rail. And this is the option that we wanted to investigate and also implement, which is called intermodal freight. It's a combination basically between truck, rail, or ship. And for us, concretely, it means, for example, shipping the steel tubes from a port in northern Spain, in Santander, close to our production site, to northern ports in Belgium, in the Netherlands, or in the UK, and leaving only the first and the last miles with the truck for the delivery to the customer. And on the next slide, as my colleague Frédéric also mentioned earlier, because projects are complex by design, and that we have also the experience of customers telling us that they want to approach their sourcing as a whole in terms of Scope 3 emission to reduce, not only cherry pick one low carbon material here and then the rest with a high carbon footprint. We are able to, of course, offer now these recycled and renewably produced steel tubes but also for dimensions and products that are not yet covered by this offering, green steel certificates, so that it can be taken as a whole for a full range Scope 3 reduction for our customers. On the next slide, last but not least, how are we able to justify our numbers? Again, with environmental product declarations. My colleagues also explained very well this document. Here, what's interesting to note is that we have EPDs also for the past couple of years for the main categories of our traditional products, hollow structural sections, seamless pipes, welded pipes, and of course, the last development since a few, if you can click, Pascal, since few days actually, the EPD is also available for the offering that I just mentioned, X-Carb recycled and renewably produced steel, hollow structural sections made in Fabril, with a very competitive carbon footprint of 640 kilograms of CO2. And that's all for the tubular part. I thank you for your attention.
Well, I don't need to reintroduce Marion, so she will take again the floor for a few minutes, and then we will go on the several questions that we already received via the Q&A, so don't hesitate to type your question. Thank you.
So to wrap up, we can see here on the slide the different EPDs that we have recently published for our X-Carb family. So you can see sections, heavy plates, tubes, and so on. We have several of them, and it is important to remind you that these EPDs are standardized documents which have been externally verified, and they really quantify the different environmental impacts of our products. And it is using these documents that you will be able to perform life cycle assessment and to really scientifically assess the environmental footprint of your projects. So then if you go on the next slide. So here we have been talking a lot about low carbon materials, the different EPDs that we have, the different initiatives that we launched to decarb the manufacture of steel products. And indeed, choosing low carbon materials is of significant importance, but it is not sufficient. We should not stop here in our approach to decarb construction. We should, on top of this, use a clever design to further reduce the carbon footprint of the project. So what do we mean when we say clever design? Well, it can cover very simple things, but we should really try to think of the project as a whole and not try to optimize one element right and left, but to really make having this holistic picture and really make the global optimization of all the criterias and trying to leverage on everything which is possible for us as structural engineers. And here on this slide, I provide a very, very simple example, but which will be clear for everyone. For example, we are for a couple of years developing high strength steel. And if we are using higher steel grades with higher yield strength, globally speaking, we can reach a lighter superstructure. So of course, first of all, we will be able to decrease the total amount of steel required for the same purpose. So we are directly not even talking about low carb material, but because we have less steel, we have a lower environmental impact. But also because if the superstructure is lighter, directly it will have an impact on the foundations. We will have less foundations as well. So we will once more decrease the total amount of material which is needed for the project. So it's really playing these kind of holistic thinking that we will be able to reach effective reduction in terms of carbon footprints. Next slide, please. Yes, and so we have made some examples here with intelligence engineering, and we can show that designing a building in the right way, so I'm saying the right ways, using these clever structural approaches, we can already decrease its carbon content by around 40%. So we really need to keep these both aspects in mind, low carb material, but also efficient structural design. And so if you're interested into these case studies, of course, don't hesitate to contact us. We don't have time today in the frame of these webinars to talk about these case studies, but they're publicly available, and we'll be happy to take you through these examples, which have been made for different type of projects, offices, warehouses, industrial buildings, and so on. And that is the final slide. To simply tell you that we're here to support you on your journey. First of all, as steel manufacturer, of course, it is highly important that we decarb our production. And today, I hope that we could give you rough summary of everything that is taking place in here. But on top of this, we are also here to provide you technical assistance and to assist you in your journey, to advise you on the best structural systems for your given project, to identify carbon intensive elements, to develop appropriate strategies, that kind of things. And we have a dedicated team for that. So really do not hesitate to contact us. We have a lot of things to say in a very short amount of time today. So I hope everything was clear, but in case you would have quite generic questions or more specific questions related to your specific project, we are always available to try our best to answer your queries.
Okay. Thank you, Marion. Thank you, everyone. Warm thank you to everyone for the good presentation. So we get several questions, and I will answer right away to one question, which is about the presentation. So we will disclose the recording of this webinar in a few days. So you will receive an email, same as the one that reminded you about this event. So where you will be able to see the presentation, which has been recorded. So the first question goes to Marion, and actually it was on slide 9, if I remember well. Let me see if I can scroll up. When you showed the different emission for the section example, were the value cradle to gate, or was it part of the whole life cycle?
Yes, so on this table, the values were cradle to gate. They were corresponding to the production stage of the assessment. So these correspond to module, if we're back to EPDs and life cycle assessments, this corresponds to modules A1 to A3. You still hear me? We have a little connection issue, I guess, but that's okay. So yeah, this corresponds to modules A1 to A3, production stage. In all of our EPDs, we also declare modules C and D, so the end of life and the benefits and loads beyond the life cycle, so to be able to take into account recycling and reuse. But the numbers which were provided on the slide were corresponding to the production stage only. I hope you can still hear us.
Okay.
It works.
Okay.
It works. Okay. And how competitive can ArcelorMittal remain versus non-decarbonized producers, Marion?
I would say that to a larger extent, I mean, we can talk about competitiveness, of course, but it becomes mandatory to be able to provide low carb solutions, in a sense that, of course, I mean, each one of us, we need to make efforts in order to be able to fight climate change. I think this is something that we, as individuals, we have this responsibility on our shoulders to every day do our best to decrease the environmental footprint of our activities. But on top of that, for example, in Europe, we see more and more regulations coming on the market, which are providing strict criteria to meet in order to be able to build. So for example, in France or in the Netherlands, you are forced to use EPDs to perform a life cycle assessment and to showcase that your project will be, let's say, beyond a certain threshold of kilos of CO2 equivalent per meter square of your project. So of course, ArcelorMittal is at the forefront of the decarb, and we are doing our best to remain competitive, but it's really becoming a need. It is really something that we must do in order to secure a sustainable built environment. We need to be able to provide low carb solutions, and it is really becoming more and more mandatory on the European market. There are slight changes in the different countries. Of course, the methodologies are slightly there differences right and left, but globally speaking, they all rely on the use of EPDs, life cycle assessment, and so on. So it is something which is becoming key.
Okay, thank you, Marion. So the next question will go to Jordan. What would be the difference in the CO2 emissions between cold rolled and hot finish tubes?
Actually, all thermics operation require a lot more energy, more carbon intensive on average. But it depends also on a lot of variables, such as the energy mix of the country in which the production site is located. In our case, we can produce hot rolled hot operations in Rethel, in France. So the energy mix is less carbon intensive, but also other variables such as the technology within the plant. So this is exactly kind of information that an EPD can provide, and this is also one of our next steps for future EPDs. So precise value, unfortunately, I cannot provide yet, but in the future we might be able to provide this with our next EPDs.
Okay, thank you, Jordan. So the next question will go back to Marion. Don't hesitate again, because it will be the last question already. If you are a little bit shy of asking the question during the webinar, I will put the contact details of each of the speakers when I will send the replay, so like that if you feel that you want to get in touch with one of the person based on the specific presentation or topics, don't hesitate. That's really the idea of starting conversation with a lot of people via this webinar, and to continue that later on. So Marion, so what about the unique product ID along the product value chain in order to secure the circularity of the product?
Indeed, it is something we are working on, and it is fully right that we need to be able to ensure some kind of traceability if we want to deploy circular solutions. So as I said at the beginning of the webinar, structural steel has a huge potential in terms of reuse, and actually we have been following some pilot projects for which some hot roll sections have been reused. There are some guidelines within the Eurocodes and elsewhere which are being developed to provide protocols and design rules to be able to reuse steel elements. So this is something I think which is going to be key in the next years. And for this, steel is really has an important role to play. So this ID tag is relevant in the sense that either we collect an old beam and you have no idea where it comes from, and then we therefore need to make to take some safety margin and to make some conservative assumptions, for example, regarding the yield strength and so on. But if we can ensure the right traceability, so we can find back, for example, the mechanical properties of the beam, where it comes from, or the beam or something else. Here I'm using a beam as an example because we've done that for a project, but can work with other products as well. If we can, with a strong reliability, understand what are the properties and the composition of the steel product, of course, we can optimize even more the design, and this will encourage more and more circular construction. So this is indeed a very important topic. And also, I think for this, we also need to make sure that we deploy reliable numerical models of our projects. For example, beam models. If we're able to really track the structural components in the BIM model, it's an extra card in our hands to ensure that we will be able to reuse it and to deploy circular approaches.
Okay, so Marion, thanks to everyone. We still get some questions that popped up now, but I will take the decision to close this webinar because yeah, we could talk ever and ever. There are some questions that are anonymous that if those people want to ask again the question via email, so as I said, we will give the detail of each of the person in the email that you will receive with the replay. Don't hesitate. When there is a name for the question, we will directly contact you via one of our persons. So I want to thank you, everyone. I want to thank all the speakers, and I wish you a very good day. Thank you.
Thank you all for listening.